There's a theory about the very nature of reality that's so profound it could redefine everything we think we know about space, about life, and maybe even about consciousness itself. But this incredible idea was almost completely obliterated by a single flash of light that traveled for 7 billion years to reach us. Our story starts there.
It all boils down to one simple but completely radical question. What if the vast emptiness of space isn't just a smooth, featureless void? What if, on the tiniest possible scale, it has a structure, kind of like a crystal?
For a little while, this crystal universe theory seemed to explain so much. But then, a piece of evidence arrived from a distant galaxy, and it threatened to shatter the whole idea, turning a brilliant insight into what looked like a fatal mistake.
So, where did this beautiful idea go wrong? Well, the problem, as it so often is in physics, came down to one of the most fundamental constants we have: the speed of light. Okay, so this is the piece of evidence that nearly killed the theory. It's called the Fermi constraint. Back in 2009, the Fermi Gamma Ray Space Telescope saw this incredibly powerful cosmic explosion, a gamma ray burst. Now, light from that event traveled for 7 billion years to get to us. And when it arrived, both the high-energy photons and the low-energy photons hit our detectors at almost the exact same instant. So why was that such a big deal?
Well, because the simplest version of the crystal universe theory predicted the exact opposite would happen. See, if space is a pixelated grid, like a crystal, then higher energy photons should sort of bump into it more. They should get bogged down, experience a tiny bit of drag, and show up just a little bit late. But they didn't. They arrived right on time. And just like that, the theory, in its simplest form, was dead on arrival.
But, this is where science gets really cool. Instead of just throwing the whole idea out, physicists took a step back and thought, wait a minute, what if we're just measuring the wrong thing? What if this crystal structure of the universe doesn't affect light's speed, but messes like a totally different property? So the old test was a bust. The speed test, looking for that drag, was disproven. So they came up with a new one, the polarization twist test. Forget about when the light arrives. Instead, let's measure how it's oriented when it gets here. What if the crystal doesn't slow light down, but twists it?
This brand new prediction has a really cool name: cosmic birefringence. The idea is pretty simple. Normally, a photon's polarization angle, its orientation, should stay the same forever. But if space itself is a crystal, it might act like one, causing the orientation of light to slowly rotate as it journeys across the universe. And this could happen even if the speed of light stays perfectly, absolutely constant, which neatly gets around that whole Fermi constraint problem. To really get this, we need to picture what polarization is. It's basically just the direction that a light wave is wiggling. You can think of it like a corkscrew pattern flying through space. Now imagine that corkscrew traveling for billions of years. In this new version of the theory, the entire corkscrew pattern would slowly, subtly rotate along the way. Here's a great way to picture it. Think of space-time as a block of wood that has a twisted grain running through it. Now, a photon has a property called spin, which is kind of like the handedness of a screw. It can be right-handed or left-handed. And just like a right-handed screw might move a little differently through that twisted grain than a left-handed one, the universe's structure could interact differently with each type of photon. That tiny difference, stretched out over billions of years, would cause the light's polarization to twist. So the theory was saved, and it came back with this new, very specific, testable prediction. If the universe really has this twisted, crystal-like structure, if it has a handedness, then we should be able to see the evidence printed on the oldest light in the entire cosmos. The target? The cosmic microwave background, the afterglow of the Big Bang itself. If this theory was right, the polarization of that ancient light should be just slightly rotated from what all of our standard physics predicts. All scientists had to do was look for that tiny twist. And in 2020, after sifting through mountains of data, they found a number. A tiny, almost imperceptible rotation of 0.35 degrees. This analysis came from physicists Yuto Minami and Ishiro Komatsu, who were looking at data from the Planck satellite. It gave us the first, really tantalizing hint that this cosmic birefringence thing is actually real. Now, it's not definitive proof, not yet, but it's a potential smoking gun. The very first clue that the fabric of space isn't perfectly symmetrical after all. So, what would it mean if the universe has a hand? It would mean space-time isn't random. It has a preferred direction, a kind of asymmetry that's woven right into its fabric. It would mean the universe has an internal geometric structure, just like a crystal.
And this is where the implications of this theory get really, truly mind-blowing. Because if the universe itself has a fundamental asymmetry, it might just hold the key to unlocking one of the deepest mysteries of all, the asymmetry of life itself. Think about this for a second. It's a stunning parallel. Physics is now hinting that the universe prefers one spin of light over the other. Meanwhile, right here on Earth, biology has an undeniable preference. All life is built from right-handed DNA and left-handed amino acids. Why? Out of all the possibilities, why that specific combination?
Well, maybe it wasn't a random choice at all. What if the fundamental geometric handedness of the universe itself imprinted its structure onto the very first molecules of life, basically setting the template for all biology that would ever follow?
This is just a fundamentally different way of seeing the cosmos. The standard model gives us a smooth, random, sort of chaotic universe. But this new theory points to a universe that is pixelated, geometric, and self-correcting, one that has an inherent structure and order built right into it. And the rabbit hole could go even deeper, right into our own minds. Some physicists are starting to speculate that the very same geometric principles, the same crystalline math that structures the entire universe, might also be at work inside our brains, maybe in the tiny structures of our neurons, helping to give rise to consciousness. And that leaves us with one final, profound question to think about. Is our awareness of the universe not just something looking at it, but a fundamental reflection of it? Could the geometry of our thoughts be a direct echo of the geometry of space-time? A theory, once on the very brink of collapse, now offers this incredible, potential connection between the cosmos and consciousness.